Right, so in this video we're going to be having a look at the Vertex Interpolator. Now this is a slightly more complex node, but hopefully we can have a look and see what it is doing. So I have here a sphere radius or sphere gradient 2D node. That is might be different to what you have in your examples if you're following along, but it's just a inbuilt node. Sphere gradient 2D shows this effect quite nicely, and what it's giving us is a 2D circle based on the UVs of the plane, and we get this shape. Now this is being calculated per pixel, and so if we have a look at our plane, there's a lot of pixels, but not many verts. And what we can do is the Vertex Interpolator can push a calculation to be per vertex instead of per pixel. And so if I plug this through here, what's going to happen is that sphere is now being calculated per vertex, and you see we're getting the sort of diagonal lines, and you can almost kind of see the wireframe of the grid of the mesh underneath. Now that obviously visually looks quite different, but performance wise it's going to be much cheaper to calculate. So it's up to you if you decide whether parts of your material can be calculated on the vertex shader rather than on the one per pixel. Now another advantage of this is that if we're using object position, which again we'll cover in our input data classes next, we can also, by putting this through the Vertex Interpolator, get the position of instance painted foliage actors or instance actors. So object position for a painted amount of foliage isn't going to give us per instance position, it's going to give us the center point or the object position of the sort of group of foliage as a whole. So we can't use that to do randomization, and we'll cover doing randomization based on position in another class as well. But the important thing here is by putting it through the Vertex Interpolator, we can get, and in fact if I just do it this way first and not do that, so in this case we're just taking the position, dividing by a value and giving us a frac result. And so there's 6 here, I've got the use instances enabled, so these 6 are instance actors, and you can see they're the same value. It still randomizes, still changes based on position, as you can see the color changing there, but it doesn't do it per object. That's not very good for randomization, but if we do it through the Vertex Interpolator, what it's going to do is calculate the object position per instance, and now we get different values, and as we move you can see they're changing differently, which works quite nicely. So as I say, we'll cover that in more depth when we look at object position and input data, but the Vertex Interpolator that we're looking at here either is a really good optimization tool if you're doing calculations that can be per vert rather than per pixel, or can be a way of accessing instance position rather than object position, which can be really useful for randomizing on instances.